Okay, so in today's lab, you're going to have to be able to calculate energy based on the SI unit of energy, the joule, which is how energy is measured. And we can measure energy in many different ways, including watts, kilowatts, calories, horsepower, but we're going to focus on joules. So to recap, energy is the capacity to do work. Energy is what makes things go. So there's energy all around us. It comes in both kinetic and potential. So kinetic energy is the type of energy that a body possesses by virtue of it being in motion, whereas potential energy is the energy possessed by a body by virtue of its position relative to others, stresses within itself, electric charge, or some other factors. Now we are going to focus on kinetic energy here, not potential energy. And we use, of course, like I said before, the joule. A joule is defined as the energy needed to push a 1 kilogram mass a distance of 1 meter in 1 second. So if you can push, or if you push something that weighs about 2.2 pounds, 1 meter in 1 second, you have just exerted 1 joule. If you push that object, if you push a heavier object, like let's say a 2 kilogram object, 1 meter in 1 second, well, you've exerted 4 joules. It goes up by a factor of 4 when you double the mass of an object. So there's also the watt, which is 1 joule per second, and the kilowatt, which is how electricity consumption is measured. A kilowatt hour basically works out to the energy it takes to keep a 100-watt light bulb lit for 10 hours. And it equals over 3.5 million joules, or 3.6 megajoules. So joules are pretty small units of energy. Now, keep in mind with these units here, when we say kilo, that means you have 1,000 of something. Mega means a million. So you can see there we changed 3,600,000 joules to 3.6 megajoules. Makes it a little easier to read. Giga means a billion, and tera means a trillion. Okay, the formula for kinetic energy, which is what we are going to focus on today, is kinetic energy is equal to 1/2 times the mass times the volume squared. Your mass must always be in kilograms because these are SI units, standard units that we use all throughout the world. And your velocity has to always be in meters per second. You cannot do this by doing pounds for your mass and miles per hour for your velocity. It will never ever work. So because we live in America and we measure things by miles per hour or feet or inches and pounds, we have to do some extra conversion. So what we're going to do here is we're going to take something we're all familiar with, a fastball. We're going to calculate how much energy a 100 mile per hour baseball has. So our first step is we have to convert miles per hour to meters per second because we have to convert the language we speak to the language the rest of the world uses. So we go from left to right here. We're going to start with 100 miles in 1 hour. Our next step, we're going to convert our miles to kilometers because kilometer is based on the meter, which is SI, whereas miles are not. And on the bottom, we have to put how many miles are in a kilometer, 0.621. Next step, we're not doing kilometers per second, we're doing meters per second. So how many meters are in a kilometer? It's 1,000, that goes up there. And then we got to do our unit of time. So we're doing miles per hour, so we need to break that down to seconds. First, we need to do minutes. There are 60 minutes in an hour. And then we need to take that minute and break it down, and there are 60 seconds in a minute. Now, if we look at this, what we have here, if you go kitty corner, starting all the way on the left, our miles cancel out, then our kilometers cancel out. Notice our meters, 1,000 meters does not transfer over to minutes, but that's okay. We can take hours on the top here, and we can cross that out with the hour we have under 100 miles on the far left. And then finally, we take our minute and we cross that out. Our 1 minute over 60 seconds crosses out with our 60 minutes under our 1 hour. And if you followed along, you can see that the only thing that didn't cancel out here was the meters, where we have 1,000 meters, and the seconds, where we have 60 seconds. And that's exactly what we wanted, because we wanted meters per second. So if you calculate all of this out, it works out to 100,000 is the top, because we have 100 times 1 is still 100, times 1,000 is 100,000, times 1 times 1. The bottom, we end up with 2,235.6. So a 100 mile per hour fastball is traveling the equivalent of 44.731 meters per second. You should be calculating this along with me as I go along. If you got something wrong, stop and keep working through it until you get it right. So going back to our kinetic energy formula, there it is. Now, I have to give you the mass of a baseball, which is 145 grams, but we need that in kilograms. So remember, kilo is 1,000, so we move the decimal place 3 places to the left, which is what happens when you divide by 1,000. So there's our mass of our baseball, 0.145 kilograms. Now I took the formula on the top there and I broke it down and put things in brackets to make it a little easier to understand. So instead of 1/2, I just put 0.5, same thing, times the mass of our baseball, times the velocity, which we calculated in the last step, squared. Now, I want you to calculate these numbers out, and what you should get is 145.06 joules. Now, if you got 10.517 joules, that means you did your order of operations incorrectly. Remember, please excuse my dear Aunt Sally. We have to do exponents before we do anything else. So if you do this formula and you just go left to right, 0.5 times 0.145 times 44.731, and then you square that, you get 10.517. But that's not the answer. The first step, you have to do the exponent. So we need to square 44.731. Then you can multiply times 1/2 and then times 0.145.